Good afternoon to all. Myself, Dr. Shanmugam, the Department of Science and Humanities, and I would like to present my topic is quantum confinement. See, the definition of quantum confinement, the process of reducing dimension of a solid such that energy levels inside the material become discrete, smaller to those in atom. When size of the material becomes the comparable to the de Broglie wavelength of electrons, the continuous energy band split into discrete quantified energy states. So at extremely the small dimension, thin plates or isolated electrons are formed, causing materials to behave like artificial atoms with turnable electrical properties. The next slide is the quantum confinement. There are fabrication approaches to classify it. One is bottom-up approach and one more is top-down approach. Bottom-up approach is what is that atoms or molecules assembly to form low-dimensional structure. There are few examples are there: self-assembly, chemical synthesis. And one more top-down approach, the material is removed from the bulk solid to reduce the size. There are examples, lithography and etching. So both methods can produce a structure small enough to exhibit quantum behaviors. The next slide is quantum structures. The quantum structure is what is that when bulk material is reduced in size that at least one of its dimensional lies into the nanometer ranges. Nanometer ranges in the sense 1 to 100 nanometer. 1 to 100 nanometers. So they're reducing any of the three spatial dimensional length, width, and height confines the region in which electrons can move. So that mentioned over here. The next slide is the quantum structures that categorize in the three basic dimensional. One is quantum well, that is the 2D structure. One is quantum wire, that is 1D structure. The quantum dot is 0D structure. So what are the types of 2D structures? The types in the sense we have to elaborate in discuss with the structures. So definition is one dimensional and free to move in two dimensional is resulting structure is called quantum wave. The construction, the formed alternating layers and different semiconductors depositing and ultra thin metal films. The explanation is what is that this one is XY plane and confined along Z axis. So from here is diagram. So these are the quantum well structure. See, the structure is like that. Okay. So next one is use quantum wells are widely used in semiconductor lasers, LED photoelectrons, and high electron mobilities. And the quantum next structure is 1D structure. What are the definition? When electrons are confined in two mutual perpendicular directions and free to move in only one direction, the structure is called quantum wire. So these are the structure of quantum wire. See, the explanations is X, Y, but they are free to move along with the Z axis. The examples are nanowires, nanorods, and carbon nanotubes. The next is quantum dot. What are the definition? In the scale is all three-dimensional or confined to nanometer scale. The structure is quantum dot. So what are the explanations? They confined all the directions and cannot be moved freely. So these are the major. What are the uses? Quantum computers, lasers, bioimaging, and LED displays and photovoltaic devices and all. So this comparison of the structure in the sense, see the bulk one, well, quantum wire, quantum dot in the different structure over here. So this one is partial confinement and more confinement something quantum wire, total confinement. So the regarding tables also, we are mentioning that what are the examples from here. 0 dimensional in the sense it will be moved 3 dimensional and 3D silicon and 2D, 1D, 0. So these are the quantum structures. Thank you for giving me this opportunity for Sri Shanmuga Educational Institutions.